Before starting a video conference, I'm usually cleaning up my windows to avoid unintended sharing. Like in this example where I have Calendar open and I minimize to the dog and Notes which I put behind another screen. And then when the software asks for screen access for the first time, this must be allowed through the system settings. This is because screen access is a permission protected by TCC, which stands for Transparency, Consent and Control. Then the app restarts automatically and I can go on with sharing my screen. For this particular app, macOS shows the warning that it is bypassing the system's more privacy-friendly window picker to access the screen directly. The dialog asks to either allow access or to go to the system settings to make changes to the preferences. Yet, even before I explicitly allow access, you can see that the folder that was previously empty now contains a ton of screenshots. Clicking through them, we can find both apps. The Notes app that was previously hidden behind another window, and also the Calendar app that was minimized to the dock. This new warning was introduced as of macOS 15.1 as part of Screen Capture Kit. But as you can see, it is not really effective and gives a false sense of privacy. Stefan noticed this behavior a while ago with the Strongbox app, which scans all open windows for QR codes in the setup phase and could find the QR code before the user would allow access. We both found this very weird, created a standalone proof of concept and reported it to Apple last summer, who just closed it as expected behavior. Since TCC is working correctly, they consider the secondary dialog's purpose to inform users when applications use non-standard picker implementations. In their opinion, it's only a transparency feature, but not a permission gate. But if this dialog is not a TCC feature, what else is it? Let's dig a bit deeper into its implementation. On macOS 15, the TCC database is still located and accessible in the system and user directory, where we can see that the secondary dialog will not cause any changes to the database. When we trace the XPC communication of our screenshot proof of concept, we can see that it communicates with the replay daemon to obtain the screenshots. As replay plays a central role here, but we don't understand this implementation yet, we can just run our proof of concept while getting verbose log information from this daemon. Looking for the app name Screen Record App Proof of Concept, we can observe a call to SCAlertStatsManager Setup Current Approvals. Here, SC stands for Screen Capture. As we are seeing an alert and to some extent approve it, this method name sounds interesting. With Reader, we can get a shared instance of the SCAlertStatsManager. This allows calling the Setup Current Approvals method again, such that it would refresh its information and hopefully show us where we got it from. In the log, we can already see that it runs its logic again. To see if it's reading a configuration file along this process, I'm hooking the open function with FreeDATrace. And indeed, it's using the file screenCaptureApprovals.plist. By looking at this file, we can see that it contains when the dialog was shown. We can even trigger showing the dialog a second time by deleting this file. Viewing or modifying this file is only possible on Macs where system integrity protection is disabled, so at least regular apps cannot modify it. But the next time you're allowing screen access to an app, better think twice.